Hello and welcome to Module 7. In this module, we're going to be talking about biogeochemical cycles. So here's that, it's a pretty big word, but we can break it up into biological, geological, and chemical cycles. And while all nutrients that are essential to life cycle through nature, the cycles that are the most important to plant productivity that we'll be focusing on the most are the water cycle, the carbon cycle, nitrogen cycle, phosphorus cycle, and the sulfur cycle. So, and these others here, calcium, magnesium, potassium, we will talk about them briefly, but they are not one of the most essential cycles for us to talk about. So why does matter cycle? Well, matter cycles simply because the available nutrients would be quickly used up if they didn't cycle through our environment, and they would be unavailable to support life. And this is different from how energy flows, because energy is a constant one-direction flow starting from the sun, going through food webs, and then dissipating back into the atmosphere and space. However, unlike energy that comes from the sun, all nutrients on Earth come from Earth, and therefore must be recycled in order to be replenished. Okay, the first one we'll talk about is the hydrologic cycle, and notice that you've learned this before. The hydrological cycle is just the water cycle, so you should know this pretty easily. So the water comes down in the form of rain or precipitation. It goes down into the plants, and then it goes down into groundwater or surface runoff. Then it is evaporated back up because of the solar heating. Comes from the plants, comes from the soil, comes from the water, goes back up into the clouds, comes back down. That is the hydrologic cycle. We're not going to focus on it because you have learned it many times. It is important that you know these words though: transpiration, evapotranspiration, and runoff. Those are the parts of the hydrologic cycle. And then let's look at this math. I'd like for you to look this over on your own, but then I'd like to show you here. So we've got each tree requires 20 liters of water per day during the 6 hot months of the year. So that's about 180 days. The water must be pumped to the plantation from a nearby stream. So how many liters of water are needed each year to water the plantation of 900 trees? So you've got 20 liters of, per tree per day. That was given, 180 days per year, and 900 trees. We're just going to multiply that out. The answer is 3,240,000 liters. So it's important that you take a look at the math when we go through these, and you know that that could be an example of what you would see on your test. All right, the next cycle that we're going to talk about is the carbon cycle. And the carbon cycle is really important. There are several different parts, and I'll expect you to know these different parts. So let's look at the cycle. The carbon cycle moves through between the air, water, and the land. That's an important distinction. So we'll see that as things are combusted, and volcanoes, and also respiration and photosynthesis, carbon dioxide goes into the atmosphere, then it returns to the producers via photosynthesis, and at that point it can be taken up by decomposers or consumers. Then eventually it can become buried, can become a fossil fuel. Same thing is going on in the ocean, and then it will go back up to the atmosphere. The parts that you'll need to know of the carbon cycle are here: burial, combustion, exchange, extraction, photosynthesis, respiration, and sedimentation. So if I was to give you a picture like this that was out without labels, you would be able to label those things. It's pretty clear what the human impact is on the carbon cycle. We are combusting more and more fossil fuels, and that's increasing the carbon dioxide that's going into the atmosphere. We're also harvesting trees at an alarming rate, which causes the plants don't take in the carbon dioxide, and also the act of cutting them down is adding to the carbon dioxide we put into the atmosphere. All right, the nitrogen cycle is the most complex of all of the cycles that we'll be talking about, so know that we'll be going over it quite a bit in class. The things that you'll need to know: ammonification, assimilation, denitrification, nitrification, and nitrogen fixation. These are the 5 steps of the nitrogen cycle. There's a lot of vocabulary in this module, specifically even in this nitrogen cycle. This cycle includes many different chemical transformations, and you'll need to know each of them. Know that there are 6 key elements that our organisms need in pretty large amounts and those are called macronutrients. And those are nitrogen, phosphorus, potassium, calcium, magnesium, and sulfur. So we will be going over those. This is a picture of what the nitrogen cycle looks like, but I'm going to break it down a little bit more clearly. So here I've got the main nitrogen reservoirs. I'm going to put a square around them. And then the main forms of nitrogen I'm going to circle for you. So the nitrogen reservoirs are the atmosphere, also the plants and animals. That's where you will find nitrogen reservoirs. The different types or forms of nitrogen are going to be ammonium, so that's NH4 plus, sorry, that's a 4. Nitrite, which is NO2 minus, and nitrate, which is NO3 minus. And I'm going to circle this here because this is a form of nitrogen. It is just the diatomic element itself, which is N2. All right, let's add some arrows here. So going from nitrate to the atmosphere goes this direction, and this process is called denitrification. Going from nitrate to nitrite, like that, is called nitrification. And then the nitrate also goes down to the plants and animals as well. I guess I could have made it one line, and that's called assimilation. So what the plants and animals do within their bodies is assimilation. And then from there, it will go to ammonification. And ammonification actually will also go this direction. All right, so then we've got ammonium 2 nitrite. This also is nitrification. And the last one here, this is nitrogen fixation. Nitrogen fixation, sorry. And that's going from the atmosphere N2 down to ammonium NH4. Okay, so this is just the same picture, only highly simplified. Unfortunately, you will need to know, not unfortunately, it's important that you know all of these different steps that I've put here and be able to answer questions on them. All right, moving on, let's, the human impact of adding nitrogen. What we've done to the nitrogen cycle is the addition of nitrogen to soils as fertilizers. So, and when there's an excess of nitrogen in a water body, so we add it to the fertilizer and then it goes down into the water. And then when there's an excess of nitrogen and also phosphorus, which we'll talk about in a moment, it causes an explosion of an algal bloom. So that an algal bloom increases the populations of consumers that eat that algae. So the algae increases, so the consumers that eat the algae increase, and then and then there'll be an overpopulation of decomposers, and then that overpopulation of decomposers starts to die, and that depletes the oxygen level, and then makes aquatic life really hard because the oxygen level has been reduced, causing a hypoxic condition. And that we'll be talking about a little bit more in a moment. Okay, so now let's talk about the phosphorus cycle. The phosphorus cycle moves from the land to the water. There is no atmospheric form of phosphorus, so that's important to know. Let's take a look at how important water has been in each of these cycles. Water is important because it enables the nutrients to be leached from the soil and transported by streams and rivers, and then precipitated out of solution into the ocean. So nutrients in general would have a difficult time moving through ecosystems without water. Algal blooms, we'll talk about this quite a bit in chapter 14, so much later in the course when we talk about water pollution. Human impact on the phosphorus cycle, we talked about adding fertilizers that leach into the water, but also detergents. So for a long time there was a lot of phosphorus in our home detergents, in washing machines, and also in dishwashing detergent, and that was going into our waters, again causing the algal blooms. We're hoping that there is currently a ban in most states, but not in all states yet. Okay, calcium, magnesium, and potassium are all macronutrients. They're from rocks and decomposed vegetation, and they're found in soils. We are going to focus more on this section, though, on the sulfur cycle. So here's a picture of the sulfur cycle. Sulfur is a component in protein, so it is an important macronutrient. And it's important to see how it is cycled here. So the major natural source of phosphorus and sulfur is in rocks. So you'll see sulfur here down in rocks. It can be, it goes down in sedimentation and also in natural gases. The two cycles are different because sulfur does have a gaseous component, whereas phosphorus does not. All right, that's the end of module 7. So let's look and make sure that we've gone through everything. We saw the water cycle, the carbon cycle, nitrogen cycle, phosphorus cycle, and the sulfur cycle. We touched briefly on calcium, magnesium, and potassium. All right, I hope you enjoyed module 7.